Now we're going to take the quadratics and we're going to solve them. As you can see from your foldable, there are 5 different ways to solve them. Will I ask you to solve a particular problem one specific way? No, as long as you know one of these ways to solve a quadratic, then you're good to go. One thing I will say, though, is that the last 2, quadratic formula, completing the square, will always get you your solutions. Okay? Quadratic formula, completing the square, will always get you your solutions. Because graphing, if it doesn't cross exactly at like one of the intersections of like your vertical and horizontal lines, then you have no idea what that value is. Not every quadratic is factorable, and not every quadratic only has the x squared term. Okay, so depending on what you have, sometimes you can use one of the others, but quadratic formula completing the square will always work. Okay, I'm going to show you all of them. So to solve by graphing, the solution to a quadratic are its roots, aka its zeros, aka its x-intercepts. So when you're solving by graphing, your goal is to find out where does this quadratic cross the x-axis. Did everybody hear me? When you're solving by graphing, your goal is to basically determine where does this graph cross the x-axis, which means we need to graph this. We just spent some time graphing some quadratics, right? This quadratic right here, is it in standard form?
Yes.
So then that means in order for us to graph this, we need to find the what? We need to find the vertex, and then we need to do the pattern, correct? All right, so let's find the vertex. The vertex is found by doing negative b all over 2 what? What's b?
Negative 4.
What's a?
1.
So negative makes a.
Also 2.
So the positive 4 over 2 was 4 divided by 2.
2.
So 2 represents the x coordinate of your vertex. 2 also represents what other piece of information? Now the axis of symmetry. So remember that's the same formula. Okay. Just a little review from what we just talked about. Now how do I find the y coordinate of the vertex?
You plug that into
Plug 2 back into the equation. 2 squared. 4 times 2.
8.
And you have a minus 5. So 4 minus 8 minus 5 is negative 9. So 2, negative 9 represent the vertex of this quadratic. Over 2, then 1. Two, negative 9. Now we need the pattern. What's the pattern? Up 1 over 1. Well, that's not an x-intercept, so I got to keep going. What comes after up 1 over 1? Up 3 over 1. I still haven't hit that x-axis, so I do need to know, and I said it.
5 over 1.
Up 5 over 1. 1, 2, 3, 4, 5 over 1, and boom, I have my x-intercept. Okay? What is that point? 5, 0. So that's one of my solutions, or I could say x equals 5, because it's a solution, so it should be x equals 1. Now I need the one on the other side. So I go up 1 over 1, up 3 over 1, and then what's that point? So my 2 solutions for this quadratic are 5 and negative 1. What's that? Go ahead and add them. This one works because it actually crosses the x-axis at like a solid whole number point. This won't work every time. Okay? Questions? Do number 2. See if I can get the pattern. First step is I need to find the what? The vertex. What was my vertex? 4, negative 2. Okay, 4, negative 2. So 4, negative 2. Now, normally my pattern is up 1 over 1, up 3 over 1. But my A is a 1/2, which means I'm going to go up how many? 0.5 or 1/2, then over 1. Then I'm going to go up 1.5 over 1, or 3/2. 3/2 is 1.5. So from my vertex, I'm going to go up 1/2 and over 1. And then when I go up 1.5, well, here's 1, and then here's 1/2. Oops. Then I got to go over 1. And boom, I have my x-intercept. What x value is that? 6. Now I got to do it to the other side. Up 1/2 over 1, up 1.5 over 1. And that value is 2. Those are my solutions. Again, this will not work every time. Graphing only works if it happens to, cross at the whole number. If it doesn't, then you got to try a different option, like quadratic formula completing the square. Let's go through factoring real quick, okay? We factored before, and I'm trying to slide divide bottoms up or California. Which one sounds familiar? Okay, we're going to roll with that. If you're like, I have no idea what that is, and you already know how to factor, then do your thing. But those who don't remember, slide divide bottoms up. Do I need a slide here? No, I don't. Slide only works if there's an A in front. But remember, you're looking for two numbers that multiply to give you your C, add together to give you your B's. What two numbers multiply to give you 30 that add together to give you negative 11? They both have to be. So then that gives you x minus 5 times x minus 6 equals 0. That is what x squared minus 11x plus 30 factors down to be. But because I'm solving, I have to set both of those factors equal to 0. So my two solutions are going to be x equals and x equals. Okay? When A is 1, it's pretty straightforward, pretty simple, okay? But let's look at the ones where A is not 1. This is where you have to apply the slide divide bottoms up. So here, these two, I want to do both of these. I'm not going to do number 4 because number 4 is pretty simple. Okay? If you already did it, great. Let's concentrate on 5 and 6. Do I have to slide here? Yes. I slide that over. What's 3 times 6? 18. So now I'm looking for two numbers that multiply to give me 18, but add to give me 11. What are those two numbers? Are they both positive? So I have x plus 9, x plus 2. That's the slide part. Now I have to divide by what number? 3. Does 9 divide by 3 nicely? So I have x plus 3 as one of my factors. Does this one divide nicely? So I have the bottoms up. And that's what 3x squared plus 11x plus 6 equal. From here, I'm solving. Don't get caught up in the factoring thing that you forget that you're actually solving. So x equals what numbers? Very good. Can you guys do number 6? Do number 6. Slide. What's my number?
40.
And then you have to add them to equal what number? What were they?
Negative 4, negative 10.
Then I have to by 5. Does 10 divide by 5?
Yes.
So this gives me x minus 2. This one, bottoms up. Okay? Now, I'm going over the factoring part because, hey, you need to know how to factor. Okay? SAT, ACT, PERT, all those, PERT, that's like one of the major things is factoring, okay? But we're solving here. So you got to make sure that you go that additional step and you actually set both of these equal to 0 and solve. What are my two solutions? 2 and positive 4 over 5. Okay, make sure you add over that 4, then divide both sides by 5. Okay, so that's how you factor. Questions on that? No, factoring does not work every time, but gosh, look to see if it can factor, okay, before you actually try a different method, okay? Square roots, definitely not spending a lot of time on this one because the only time square roots are allowed is if the only part of the quadratic that you have is that ax squared part. If it has that bx, you cannot do the square method, okay? It only works for problems where it's just the x squared in the problem, okay? So, for example, in number 9, your goal is to isolate the x. How do I get x by itself in number 9? What do I need to do? I need to add 7 first, okay? So that it gives me 2x squared equals, what's 25 plus 7? And then I need to divide by 2. What's 32 divided by 2? So right now I have x squared equals 16. I need to get the x squared part by itself because in order to get rid of that square, I need to do what? And anytime you take the square root in an equation, your answer is always, say it again, plus or minus the square root of that number. Okay? So don't forget, plus or minus when you're doing square roots. Again, square roots are only, you can only use those if you only have that x squared term. Okay? You can have a c, it doesn't matter, but if you have that bx term, it throws everything off and you have to use one of your other methods. Okay? Let's look at number 11. How do I get the x by itself? What's the first thing I need to do? Say it again. Subtract 9. I need to isolate that squared part. What's 84 minus 9? My square part is not alone. I need to do what? What's 75 divided by 3? What do I need to do next? Take the square root. Now at this point, don't forget, when I take the square root in the equation, it's going to be what? Plus or minus. So right now I have an x plus 1 equal to a positive 5, and I have an x plus 1 equal to a negative 5. So I'm going to have two solutions here, but they're not going to be the exact same. They're going to be different because I have to do what as my final step to solve? And then the solve for x, I'm going to need to do what? Subtract 1. So when I subtract 1 from both of these, I'm going to get two different solutions. For the one on the top, I'm going to get x equals, and then the one on the bottom, I'm going to get x equals. So be careful here. They won't always be the exact same number, plus or minus. It just depends on what else is involved. Okay? But like I said, can't use square roots every time. But now we're at finally the two that you can use every single time you want to find a solution to a quadratic. Completing the square. If you don't have to, like on your SAT or your ACT and ask you to solve a quadratic, never use completing the square. Because there's a lot of steps to remember and it takes a lot of time, but we are going to go over because, hey, it's used for other things. So, these steps for completing the square. For 1, A always has to equal 1. If A doesn't equal 1, you have to divide everything by A. So we're going to do number 13. 13 is A1. Perfect. Let's go on to step 2. Step 2, we want to make sure our AX squared plus our BX are on one side and our C is on the other side. Do we have that? Step 3, you want to take half of your B term and then you want to square it. And then add to both sides. What's B in this problem? The negative 12. So when I take negative 12 and I divide it by 2, what do you get? Negative 6. Then you have to square. What's negative 6 squared? So I'm going to add 36 to both sides of this problem. Because it's an equation. Whatever you do to one side, you got to do to the other. And if you're curious, like, well, why is it called completing the square? Because technically when you set it up, there's like a blank spot right here. And so you're completing that square, you're filling in that square. Okay. And then your last step is to factor and solve. When you take half of B and you square and add to both sides, on the left side you create what's known as a perfect square trinomial, which means it can be written in this form. Okay? Just one binomial that's being multiplied by itself. And if you ask yourself, what two numbers multiply to give you 36 that add together give you negative 12? Two negative 6's. So you basically have x minus 6 times x minus 6, which is the same thing as x minus 6 squared. It always turns into a perfect square trinomial. Then on the other side, what's negative 27 plus 36? 9. And then we solve from here. So we've done the completing the square part, now we just need to solve. What do I do to solve? And you cannot forget, when you take the square root in an equation, it's always plus or minus. So this becomes x minus 6 equals a positive 3, and then an x minus 6 equals a negative 3. What are my two solutions? 9 and x equals 3. And that's how you solve a quadratic by completing. That one will work every time. No, your numbers will not always be whole numbers. You might have some simplified radicals. Okay? So be aware of that. As long as you double check your work, then you're good to go. Let's look at number 14. Don't forget your steps. It's 4 steps. And number 14 is A1. No. So to make A1, I have to divide every single term by 2. So that turns into x squared plus 6x plus 5 equals 0. Second step says to make sure it's in the form of ax squared plus bx equals c. Is it? So what do I need to do to make it in that form? And I'm going to go ahead and leave a space to complete my square with. Because I know my next step is I need to add it to both sides after I do some other stuff. What's step 3? You take half of b and then you square it. What's half of 6? When you square it, it becomes, so that's what goes in the square. You have completed the square. You haven't solved, you've just completed the square. Did we write down those steps? Last step is to factor and solve. Yep, that's why I always wrote it. The number that goes in this parenthesis is always this number, what you get when you take half of b every time. Every single time. That's what that number is on the inside of parentheses. What's negative 5 plus 9? Positive or negative? Now I just solve from here. So I take the square root of both sides, making sure I don't forget that I'm going to have a plus or minus 2. And my two solutions are negative 5 and negative 1. Questions? Let's talk about the quadratic formula. First off, what is the quadratic formula? Yeah.
Negative b plus or minus square root of b squared minus 4ac all over 2.
Yes. You need to know this. You need to memorize the quadratic formula. So let's use the quadratic formula to solve this. Quadratic formula will work every single time. If you have to choose which way, quadratic formula is the best way out of completing the square and this. You want to make sure that it is in standard form so you have your A, B, and C where it needs to be. What's A in number? Let's do number 18. What's A in number 18?
6.
What's B?
5.
And what's C? Okay, I always like to write them out just to make sure that I don't make any errors when I plug it into the quadratic formula. So here we go. We have negative b plus or minus square root b squared minus 4ac all over 2a. And then you just plug it in, okay? So you have b squared minus 4a. That's right. I hear someone singing in the back. All over 2a, which would be 6. Okay? So, what's 5 squared? Now you need to do, yes, you guys can do this without a calculator. What is 4 times 6? 24. What's 24 times 4? 96. And since you have a minus here and a negative here, is that going to be a minus 96 or a plus 96?
Plus.
All over, what's 2 times 6? 12. Now what's 25 plus 96? Say it again. I didn't hear you. Is it 121?
Yes.
121. Now, is 121 a perfect square?
Yes.
What is the square root of 121?
11.
11. So that means you're going to have two solutions here. One where it's negative 5 plus 11 over 12, and one where it's negative 5 minus 11 over 12. What's negative 5 plus 11? 6. What's 6 divided by 12? 1/2. So 1/2 is one of your solutions. And then what's negative 5 minus 11? That doesn't go in evenly, but it can reduce. Positive or negative? They're your solutions. Yes, you can have fraction answers. Okay? No need for a calculator. You guys got this. Let's do 20 and we'll call it a day. Sound good? Okay. Let's do 20. Is it in standard form?
Yes.
Then let's find out what A is. What's A? 2. What's B? Positive or negative? Watch your signs. It is a negative. And what's C? So let's plug it in. Negative B. Well, B is already negative, so what does that mean? It's going to be a positive. So we got negative B. Then we got plus or minus square roots. What comes next? B squared minus 4AC. So that's, bless you, that's B squared minus 4AC. How's it in? All over 2A. What's A? Make sure you plug it in correctly. Don't lose any signs. Okay? So we have 8 plus or minus. What's negative 8 squared?
64.
And whenever you square a negative number, it's always positive. Now we have 4 times 2 times a negative 15. What's that? What's 8 times 6? Huh? And will it be a positive 120 or a negative 120? 2 times 2 is 4. What's 64 plus 120? So we have the square root of 184 over 4. Or 8 plus or minus the square root of 184 over 4. Now, is 184 a perfect square? No, it's not. That doesn't mean that we can't do this. It just means that it's not going to be a whole number or a nice fraction. Okay? What we need to do is we need to simplify that radical. So we got to go back into your Algebra 1 days. Okay? What numbers multiply to give you 184? That's true. 1 and 184. You can never forget about those. Is it an even number? Yes, it is. So you know it's 2 and 92.
Miss Anderson?
Is it divisible by 3? No. The 18 is, but not the 4. What about 4? Is it divisible by 4? 4 and what? 40, 46. Okay? See, quick thing, does anything else work? I'm gonna let you know now, nothing else. Okay? Alright, just because we're kind of running short on time. But go through, okay? But your main goal is to find the factors that multiply to give you that number, and one of them needs to be a perfect square. Are any one of these a perfect square? 4. So the square root of 84, and I'm using the space because I can, breaks down to be the square root of 4 times the square root of 46. What's the square root of 4? 2. So this becomes 8 plus or minus 2 root 46 over 4, and then 8 minus 2 square root of 46. You'll want to make sure that you simplify that radical. No, they're not integers. They're technically irrational numbers. Yes, but we're not done. Because isn't there a number that can go into 8, 2, and 4? 2. You want to make sure that you reduce. Always, always, always reduce. And since 2 can go into 8, 2, and 4, and I'm talking about the number on the outside, you never reduce what's underneath the radical. That becomes, your two solutions become 4 plus the square root of 46 over 2. And then 4 minus the square root of 46 over 2. These would be your two answers. They're not integers, they're not rational numbers, but they are solutions and they are real. So that's how you use quadratic formula to solve a quadratic, how you can use any of the methods to solve a quadratic. Yes, and ones like this where it doesn't simplify to be two either rational or integers, then yes, you could write it as the one fraction 4 plus or minus the square root of 46 over 2. Yes. Other questions?